Good evening, sir.
Good evening, sir.
Okay, I will mute myself till the participant comes.
Hello. Hello. Sir Nagaraj sir. Welcome sir. Okay sir.
Yes, Srinivas Garu. Yeah, I am waiting for the participant, sir, because it is online program. I think always we need to wait for 5-10 minutes, I guess. Tell me, sir, whenever I want, I can start. You just notify me. I will start the class. Good evening, everyone. We are waiting for the participants to join.
Sir, 275 members, sir. Nagaraj, sir.
Yeah, I am not bothered about
Sir,
the.
your voice is not audible.
My voice is not audible, sir. Am I audible?
Yes, sir. Sir.
Yeah, I am not worried about how many people joined, sir. You tell me to start, I will start.
Okay, sir. Okay, sir.
Sir, Nagaraj, sir, continue, sir.
Okay.
Continue, sir.
A warm welcome to all of you on behalf of the Department of Computer Science and Engineering, National Institute of Technology, Nagaland, and the host institute, Swarnandhra College of Engineering and Technology, Autonomous. So welcome to our day 3 of our data structures program using C language. On first day, we understood the significance of data structures. Yesterday, we had some kind of insights about pointers, the memory addresses to some extent. Today, I am going to introduce a new concept in pointers that is called as double pointers. I hope I am audible to everyone. After introducing the double pointers to you, then I am going to explain the reason behind the memory addresses which are going to get displayed from our program. Yesterday we saw only one address. Always it is coming same. Okay. And we saw the next address of pointer is coming before the address of the variable. What I mean to say, yesterday, let us just show you from where we stopped yesterday. We are going to begin from that point today. Many people got a solid doubts always, like when I am displaying the address of I and address of PTRI, when I am displaying the address of I and address of PTRI, many people started asking in the chat box, such as, for example, yes, we have the executable file. So let me directly execute the file. Now, many people got a doubt, especially about two things yesterday. The first one is address of I is 2686764. Address of PTRI is 2686760. That means PTRI gets an address prior to. See here, in the program, we wrote something like this. I is declared before PTRI. Before PTRI. Correct? Int I, comma, star PTRI. It is not int star PTRI, comma I. First I is declared, then PTRI is declared. But why the address of PTRI is before I? Many people got a lot of doubts on this, right? So let me start from here. Let me start from here, but I will first explain double pointers. I will explain double pointers. After that, I will come back to the concept behind the addresses which are coming before, after, something like this. Okay. So let me take the screenshot of this particular screen so that I can share with you later on. So let me clear the drawings. Let me clear the drawings and start. Let us try to, means I already wrote a program like pointers, double pointers .c. Same program of yesterday, I have extended it. I have extended it. If some people may have a doubt, okay, it is written something before, so I don't know, somebody might have done a magic. So I am deleting that program. I am deleting the program which was existing already. And even I will delete the executable file also. Okay, now you see there is no magic. Only one program was there which I explained yesterday. So in front of you, let me open another double pointers.c, npp pointers double pointers. Okay. So let us keep a single line comment is double slash. To understand the concept of pointers and double pointers. So what is a pointer? Pointer is a variable which stores the address of another variable. Even pointer is also a variable, but it is a special variable. Okay. So a pointer is a variable which stores the address of another variable. That is very much clear yesterday. So let me start the program. I am including the standard input output header file. Then I am starting my user defined function, which is mandatory, that is main. Then int I equal to 345. I equal to 345. Or I can give in the same line I star ptri. So I am taking one pointer and one normal variable. I equal to 345. A value has been assigned. A value has been assigned. So printf I equal to %d I. We already know what is star ptri. Star ptri is equal to I. Everybody knows it. Okay. So it is about star ptri. Star means value at. Value at address of I is 345. Similarly, I can also simply print ptri equal to I am just typing the previous program, yesterday's program, and I am going to extend it. ptri. I can also say printf address of I is equal to %d ampersand I. And the final print which we understood yesterday is address of ptri equal to %d ampersand ptri. So I rewrote the program again within 1 minute or 2 minutes, right? So I rewrote the program. I have not introduced the concept of double pointer. Okay. So for a safety purpose, let me compile it so that I will be sure that I wrote all the syntax correctly. Let me create the executable file. From here, I will introduce you the concept of double pointers. Okay. \n is missing. So let me keep the new line character so that we will get the output in a proper manner. Oh, sorry, I have to re-execute. Sorry, I have to recompile because any modifications done, we have to recompile so that a new executable file comes. Now you can see star ptr equal to 0. Why? Okay, I missed one line. ptri is equal to ampersand I. Yeah, that's fine. PTRI in the, so there is a small mistake, that's fine. So I am recompiling it. Yes. Now you can see the address of sorry, I value is 345. Through the pointer also I got 345. Address of I is and PTRI is same, and PTRI pointer is stored in an address before the pointer. Now, when you are able to store the address of a variable, when you are able to store, so what is the concept of having a double pointer? What is the concept of having a double pointer? That is what we are going to understand. So before writing a program, just see, variable has address, obviously, and also value. A variable has address and also value. We are not worried about the value here. When we are talking about pointers, we should always think about the concept of address, but not the values. Okay, then by using a pointer, we could store the address of a variable. Correct or not? Everybody will agree with me. Yes, it's true. By using a pointer, I could store the address of a variable. Fine. Now here, observe that a pointer also has an address. It's very clear. Every variable has to be stored in the primary memory. Every variable has to be stored in the primary memory. That means you take a pointer, you take array, you take structure, you take union, you take a string. Everything needs to be stored somewhere in the memory during the program execution. So what is the guarantee that pointer has an address? You can see in the program itself. You can see here, address of PTRI. See, I am exactly keeping here. Address of PTRI equal to 2686760. That means a pointer also has an address. That means when you are able to store the address of a variable in a pointer, then it is also possible. It is also possible to store the address of a pointer. Address of a variable is stored in pointer. Because you are able to store the address of a variable in a pointer, and the pointer also has an address, it is also possible to store the address of a pointer in another pointer. In another pointer called as double pointer. In a simple understanding, in simple terms, let us not write so much of lengthy English statements. In a simple terms, variable address is stored in a pointer. Simple. Then pointer address is stored in a double pointer. So now tell me, what is a double pointer? Double pointer is a pointer basically, which holds or stores the address of a pointer. Pointer means always think that which holds an address. Now tell me, when you can store the address of a pointer, a variable, We are able to store the address of a variable. Yes, we are able to store. We are able to store the address of a pointer. Yes, we are able to store. Then double pointer also has an address and it can also be stored. Then that pointer is called as, you can say, triple pointer. There is no such word because we don't usually use triple pointers. But what is a triple pointer then? What is a triple pointer? A triple pointer is a pointer which holds the address of a double pointer. It's very simple. That means you keep on, now triple pointer as an address. You can also store in another pointer. That will be, I don't know what kind of terminology we can use for that. 4 times, right? After that, that also will, that means any number of level, any level you can go. It's limitless until unless you have a place in RAM. You can keep on storing the one address in another address, another in another address. It is like a treasure hunt game. It is like a treasure hunt game, indirect addressing. Nobody will put a gift in the first hint. The first hint will tell another hint. Like that, so many level of hint will be revealed one by one. And finally, in one place, the gift will be placed. The treasure will be placed. Are you able to understand? Are you able to understand? Now, let me come here and tell you is one more small concept. Like, okay, here itself, there is no need to write. Let me take the screenshot. Let me take the screenshot. Yes. Now, I have taken the, so I am again writing. A double pointer is a pointer which can store the address of any pointer. Any pointer means it should be a single. A double pointer cannot store the address of another double pointer. Always remember, double pointer will store the address of a pointer. One double pointer cannot store address of another double pointer. Okay, I think that is by default understood by you. Now, everybody please observe how to find the difference between a variable and a pointer. How to find the difference? It's very simple. A variable and a pointer variable and a pointer are differentiated by making use of a special symbol which is, everybody know, star. It's a special symbol, star. Everybody knows this. Yesterday we saw, for example, int I, int star ptri. See, there is no need to always write ptri. You can also write p. But my way of giving the variable names is always very meaningful. ptr is pointer of I. That is what I am writing, always ptri. If then the variable is I. Suppose if the variable is a, I will always use ptra. And I recommend such kind of naming conventions to all the young engineers. Okay. Now, then how to find the difference between a variable, pointer, and double pointer. There should be a difference, right? Otherwise, suppose, for example, if I say int x, if I say int star ptr x, okay, then it is only a variable and a pointer. Then I can say, see here, you should not concentrate on integer. You should not concentrate on the data type. Please concentrate only on the symbol. Please concentrate only on the symbol. Either int float does not matter, right? Data type is a different concept altogether. You have to say 2 stars. So a variable and a pointer are differentiated by making use of a special symbol star. Then a pointer and a double pointer are differentiated by making use of star, by making use of something, right? Like star for pointer and 2 star for double pointer. It is like a Bahubali movie, multi-star movie, right? 1 star is Prabhas, another star is Rana. If you have triple pointer, then multi-star movie, right? And 5 stars, 6 stars, you can keep on doing it, right? So jokes apart. So I say DPTRX. This is my naming convention. There is no need to write DPTR. You can also write anything. See, I put DPTR because double pointer of X, something like that. Okay. So that is how you actually define. This is the theory part. This is the minimum theory that is required. Now let us see the program. I will give a 2 minutes break now. Take a 2-minute break and we will resume the session. Just a 2-minute break. Okay, so let us resume the session. Sorry for the in between interruption. Okay. So till here, any doubts? Please respond in the chat. If you have any doubts, please respond. Now let me clear all the drawings. When exactly the memory is being allocated? Yeah. Devanshi Mishra has asked a doubt. She is our student at NIT Nagaland. I am going to explain Devanshi. I have not come to that point. I will explain when exactly the memory is being allocated. Yes, I am coming to that, Devanshi. Yes. Okay. Now let us see the concept of double pointer here. If you want to declare a double pointer, so you need to write 2 stars. So DPTRI. Okay. Now, as PTRI we already know, then I can also say DPTRI is equal to address of I. If you give, it will not work because I is a variable, but DPTRI is a double pointer. So always I can say not allowed here. Hope everybody understood. Though, so PTRI, that means the address of a pointer is stored in double pointer. Address of the pointer is stored in double pointer. Okay. Now, let us go back to the display of the values as per DPTR. Okay. So I can say new line, DPTRI equal to the DPTRI value. DPTRI is equal to percentage %D. Simply type DPTRI and let us observe what will come. Then printf \n star 1 star. When you are declaring, you give 2 stars, but in print statement, I am giving 1 star. Star DPTRI equal to, simply call star DPTRI. Then printf new line character 2 stars DPTRI is equal to, again, percentage %D, then 2 stars DPTRI, and finally printf. Let us see the address of DPTRI. DPTRI is equal to star, sorry, not star, address of DPTRI. Address of DPTRI. So actually what I have done here, I have simply extended our earlier program, which was highlighted. The highlighted part from line number 7 to 13 was yesterday's program. Now we wrote one extra concept in line number 6, that is double star DPTRI, and then we tried some 4 printf statements. One is simple DPTRI, then single star DPTRI, then double star DPTRI, and finally address of DPTRI. Now let me recompile the program and see. Okay, some of the students are asking, is it possible to take same name for both pointer and double pointer? No 2 variables can have same name. No 2 variables have same name within the function. So you can't say like this. This is not allowed. Double star PTRI and single star PTRI not allowed. Hope I clarified. Please wait. I didn't complete. See, participants. Now again, some people are asking, tell me the application in real time. I have not even explained the concept of double pointer. Please hold on. Don't don't ask the doubt which I have not even covered. Okay. But I respect your anxiety, definitely. Now, let me recompile the program. After recompilation, let me execute and then show you. And now I will also explain the meaning of the addresses also. I will explain the meaning of the addresses. Now, everybody please observe. Let us try to understand the match the following. Let us try to understand match the following. Everybody please observe what was the output. The output is exactly this. I was coming as 345. Okay. I copied the output and pasted it. There is no magic here. Okay. This is the output we got. Now from the output reorganization means I want to reorganize the output statements. Reorganize the output. What is reorganize? Very simple. I want all the 345, whatever is giving 345, I will keep in one place. See here. I gave 345 star DPTRI, sorry, star PTRI also gave 345. Double star 3 DPTRI gave 345. Okay. Then address of I, PTRI and star PTRI gave the same values. I'm just grouping. Basically, grouping as per the output. I have taken the output for easy explanation. I am regrouping it. Okay. Now, ampersand DPTRI and DPTRI gave same value. And finally, address of DPTRI has given another value. Okay. Now, grouping all the addresses. Basically, address of I is, then address of PTRI is, and then address of DPTRI is. Let me copy the addresses. Address of DPTR ampersand I. This is address of I. Then address of PTRI is something. And finally, the address of DPTRI is this one. Now, let me just keep it like this. Okay. Now you people will understand when in line number 7, in line 6, what is written? Int I is there first. In line 6, int I, then star PTRI, then star DPTRI. So who came first? I. Second, PTRI. Third, star DPTRI, double star DPTRI. But if you can see the addresses, it is exactly in the reverse direction. That means DPTRI got the beginning address, PTRI got the above address of DPTRI, and after that, that means first DPTRI is there, then PTRI is there, then I is there. I will come to that. I will definitely come to that. Okay. Why? The addresses are in reverse order. Why the addresses are in reverse order? That I will tell you. But much before that, let me explain. Let me explain the meaning of double star DPTRI and star DPTRI. Okay. Now, let me clearly draw and I will try to explain both the cases at a time. The first concept, all the local variables are stored in stack. So I have not started what is a stack, but I don't want to complex the concept of stack with you. It is very simple. Stack means one end is closed, another end is open. Imagine something like this. Where is the stack? Stack is also part of RAM only. Stack is a part of RAM. It is not outside the RAM. So you can say I am not good in drawing. So this is a stack. So one end is closed, another end is open. Here I may not explain the entire concepts of stack. Only the purpose of double pointer. See, you have to place the items like this. This is in. And you can take the items also from the same end. This is out. I may not be very good in writing with mouse. Please bear with me. In and out. That means, you please observe carefully. I am going to explain the Devanshi Mishra's doubt also. When the memory is allocated, exactly at line number 6, during the compilation, in this example, during the compilation process itself, the local variables defined inside the function, when the function is called, when main is called, line number 4, line number 5, when the control comes to line number 6, immediately it will assign the memory addresses. It will assign the memory addresses. So what has been done by the system is, see, it is only an imagination of what might have happened. Okay, so it has taken one location. It has taken one location called as 2686764, and it has been allocated to I. It is very simple. I am telling you, everybody might have submitted an assignment in our childhood, right? In our school time, every time when we have to give the homework, what we will do? One by one, the students will go and keep. The most confident guy will go and keep the homework first. Slowly, one by one, we will put. Sometimes what I used to do, I know I have not written the homework properly, so I will lift some books and insert in between. Okay, that is in real time. But in our system, there is no inserting in between in the stack. Okay, so imagine this is a table. One end is closed. Imagine it is a table. This is closed. This end is closed. Only one end is open. Then what happens? Int I, a location is found, and it has kept 345 inside it. Next it came comma star PTRI. That's why it has given another location on top of I. On top of I. What is this? PTRI. PTRI. What is the address of PTRI? As we already know from the output, 2686760. Then what is this exact 60 and 64? 60, 61, 62, 63. 4 bytes are allocated to PTRI. Now, in line number 8, PTRI equal to ampersand I. What is ampersand I? Address of I. What is address of I? 2686764. So what is placed inside here? 2686764 is placed inside. It is not the value, but it is the address of I. Okay. Now I am coming back to line number 6. After I and after star PTRI, there is something called as double star DPTRI. Then what is going to happen? Again, it is going to find stack is also part of the RAM. Okay. I have not explained the complete concept of stack, but just try to understand. Stack means one side is closed, one side is open. One side is closed, one side is open. Now, the DPTRI is assigned and it also needs 4 bytes. So 2686756. What is 56 here? 56, 57, 58, 59. 4 bytes. One address location is 1 byte. Remember, one address location is 1 byte. So it needs 4 bytes. That's why when you are printing, it looks like DPTRI got the first location. No, actually the first location was for I only, but because local variables are stored in stack and stack is basically a first in last out. Okay, forget about all those first in last out. I have not touched. I will tell day after tomorrow clearly about stack. One end is open, one end is closed. Then what is going to happen? The first person who is putting a book on a table, second person will keep his book on top of the first book. But when the teacher is taking the book, she is going to take or he is going to take the second book only first. No teacher will again open all the books and take from between. I am telling in general. For example, you went to a hostel mess. All the plates are piled up. So the plate which was kept first will be taken last. So in the same way, now tell me in line number 14, DPTRI equal to address of PTRI. What is address of PTRI? Address of PTRI is 2686760. Okay. Address of DPTRI is stored. From here, let us try to understand. We already know I, PTRI, address of I, star PTRI. Now let me explain what is DPTRI. That is, I will explain line number 15. Line 15. What it is printed line 15? DPTRI. In line 15, what we are given? DPTRI. DPTRI means it is address of PTRI. What is address of PTRI? We all know. What is address of PTRI? 2686760. That's why in line number 15, the output came like 2686760. Then what is the meaning of line 16? Now, as I already told you, in line number 6, star and double star are only symbols. Star and double star are only symbols. After that, if you use star, okay, that means in line 16, we use this star PTRI, DPTRI. Okay, that means what? Star DPTRI means just now we saw in line number 15. It is 2686760. What is 2686760? It is actually an address. Now, what is star? Star means value at. Value at. Okay. Let me write here in the down. That means value at 2686760. What is there inside the 2686760? 2686764 is there inside the location. That's why star DPTRI gives 2686764, which is equal to PTRI also. Are you able to understand? Now, what is line 17 doing here? I will write here. Line 17, the most important line. It says star star DPTRI. Star star DPTRI. That means break the line. Break it like this. First break it like this. After that, let us see. What is star? Value at. Value at. Let me copy like this. Value at DPTRI. What is star DPTRI? Just now we saw in line number 16. Value at 2686764. Go to the location 2686764 and tell me the value. It is nothing but 345. That means I star PTRI and double star DPTRI is actually giving the value of I. That what does it mean? The name of the variable will give the value of the variable. The name of the pointer with one star gives the same value, and the name of the double pointer with two stars also give the same value. That's why match the following. I have grouped it. Okay. Then what is line number 18? 18 only gives the address of DPTRI, which is 2686756. So let me write here. I don't have place. Yeah, let me write here. Line 18. Ampersand DPTRI, obviously 2686756. Right? Any doubts? Any doubt? Please let me know. I might have scribbled so much of content here. Let me take the screenshot. Now I hope everybody understood. Any doubts? Okay, is it clear? So Ravi Shankar is asking why all the variables are having continuous memory allocation like array. Very good. It's a good question. Why it is sequential? Because stack is a linear data structure. It is a continuous memory locations only. Stack is a linear data structure. Stack is a linear data structure. That means the elements are arranged sequentially. Ravi Shankar, any more doubts? Yeah, any more doubts? Mr. Swami, I already clarified the doubt. I wrote a diagram also. Stack means one side is closed, only one end is open. So either you create or you remove from the same area. That's why first I came, after that PTRI came, after that DPTRI came. That's why it looks like DPTRI is on top. Actually, DPTRI came in the third position, but it is in the top position because one end is closed. One end is closed. Any more doubts? Any more doubts? Can I go ahead with the next topic? I will give 2 minutes break here. The time is 5:58, 5:59 now. 2 minutes, you take a break. When you come back after a break, we will start the concept of structures. So I wish, let me take again the screenshot and clear the drawings. Okay, another doubt is coming from Vivek Kumar Rai, which is a very good doubt. I don't know whether this Vivek Kumar Rai is our student or not. Looks like our student, but anyways, any local variable, it does not have any concept with the data type. You give another variable like float, again it will be the sequential location only. See, all the local variables are stored in stack. Stack means only one stack. For a process, there is only one stack. So for this particular program, there will be one stack. So every variable, irrespective of the data type, will be one after the other only. So another participant is asking, explain the real-time usage of double pointer. So please wait for some more classes in our data structure. You yourself will come to know. When you are actually creating trees, linked list, you can make use of double pointers. Okay. With single pointer also, you can use everything, but sometimes you can also have a double pointer. Okay. Please wait for some time because it is too early to explain me all the concepts in the initial class without even introducing any data structure. Till now, we didn't start the data structure. We are in the background. First 4 days are background of data structures. 5th day only stack, queue, linked list, tree, graph. Okay. When I am explaining, I will come and explain you the real-time usage of double pointers. Okay, let me take 1 minute break now because I am keep on talking. Sometimes I need to have water and I need to just pause a little bit. Okay. So I am not sure whether you are able to understand the way. Sir, in the diagram shown, the address of is DPTR is actually the first record is in stack. Take the minimum address. Okay. Okay, Bhaskar Teja has asked one doubt. Like, okay, I will explain Bhaskar Teja. It's a good doubt only, but anyways, I thought it is understood by default. But anyways, I am going to Bhaskar. I am going to explain you. Let me take the screenshot again. Bhaskar Teja doubt is, correct me if I understood wrongly. His doubt is, it's something like this. Let me write here. One second. His doubt is, hold on. I may not be good in writing the drawings, but still, I will try to make the class more interactive. His doubt is, okay, this is I, this is PTRI, DPTRI. Okay, the doubt was, this is 2686764. Then this is 2686760 and this is 2686756. Why? That is the doubt. But why not? Let me just, okay. So this is I, this is PTRI, and here it is DPTRI. People sometimes, if somebody is asking it out, we may feel why they are asking a small doubt, something like that. Okay. So don't feel like that. Once any doubt is asked, and if it is very much valid, I will explain in my own pace. Okay. If it is an advanced doubt, I may tell, I will explain later. But this is a very good doubt, which was asked by Bhaskar Teja. Okay. His doubt is, why not like this? 268 6756, 268 6760, and 268 6764. The system might have done like this. First I came, you keep PTRI on top of it. Okay. This is his doubt. DPTRI. If I understood his doubt correctly or not, let me ask him. Okay. Why this? And why not this? This is the doubt. Did I understood correctly, Bhaskar Teja, your doubt? Okay. Okay, I understood his doubt correctly. Okay, now let me explain. Try to understand when one end is closed. When one end is closed, always remember this is only possible. See, the diagram itself shows, imagine the end is closed here. This is closed. Okay. When this is closed, in a stack, when you are actually, see, each process, or you can say each process means program under execution, gets a stack. Stack means, stack is a group of sequential memory locations from RAM. So when you get a group of locations and the smallest end is open, the smallest or the initial address location end is open, the last address location is end is closed. Which one is closed? Suppose you are getting 10 bytes. For example, you got 10 bytes from 100 to 1009. From 100 to 1009. Okay, here 100 location is open and 1009 is closed. That means how it will look like? It will look something like this. Okay. 1009, 1008, 1007, 6, 5, 4, 3, 2, 1, and the top one is 1000. That means this is 1000 location. And the last one is 1009. Now you have the answer. Why I is below and DPTRA is above? Why? Because 1009, when it is, see, when you are placing the item, you are going to place simple. You try to see, I have taken an empty bottle. Everybody please observe. I took an empty bottle. Nothing is there, you see. Okay, this end is closed. This end is open. When you put the first drop of water, it will reach the bottom only. From the bottom only the water is getting filled. Similarly, when the value I came, when the value, sorry, the location I came, it will go to the bottom of the stack. Are you able to understand? If you have any doubt, please ask me, Bhaskar Teja. Next, I will explain the doubt of Janardhan Kumar Patta. Why always pointer size is 4 bytes in the memory? That is the next question. Okay. The answer is, thank you. Some people are appreciating that I explained nicely. Thank you, everybody, for supporting me. Yes. Janardhan sir, the question is, it's very simple. I already explained in the earlier session of day 15 and day 16. But anyways, that's a different program of the same college. But I will tell you one thing. What value you are storing in the location does not matter. You take one example of a hostel. Take an example of a hostel. Okay. You take NIT Nagaland, you take Swarnandra College, anything. All the hostel rooms will be of same size. Who is going to store? How many people are going inside? Whether you are keeping one bed, whether you are keeping 3 beds, 2 beds, does not matter. But all the rooms will be of same size. Similarly, all the pointer addresses, the data type, sorry, there is no data type for pointer. All the pointers take 4 bytes. Irrespective of the data type of the value it is stored. All the rooms of the hotel or hostel will be of same size. Okay. Yeah, some hostels may have a different structure, but in general, I am telling, all the room sizes will be same. Why? Why? Because it's a common structure. Yes. Any more doubts? Can I go ahead? Any more doubts? Can I go ahead? Yes. That is also correct, sir. Janardhan, sir, your understanding is also correct. It is 32 bit means obviously 4 bytes is 32 bit only. That is also correct. But depends upon the machine. See, my machine is a 32 bit machine. Okay, my machine is a 64 machine. See, depends upon the your CPU also. Depends upon the CPU also. Okay. Now let us continue. Right? We are running out of time also. Yes. I hope there are no doubts now. Now let us start a new topic called as structures. Let us start a new topic called as structures. See, again the one more student is asking why the pointer take 4 bytes only. Just now I explained. Shankar Ivana, just now I explained. A hostel will have many rooms, but all the rooms are of same size. Why? Why? Because that's the structure. What value you are storing does not matter. The addresses are 4 bytes, 32 bit, 4 bytes. Okay, fine. Now, let us go to the topic of structures. Okay. So before explaining the structures, I will give a very minimal introduction. Very minimal introduction for only 5 minutes, not more than that. For the reason why we need to study about structures. Instead of talking about what is a structure, why structures are required first of all. Later we will see what is a structure. Okay. Why structures are required. Now, come to a variable. Come to a variable. Variable holds one value at any particular instant of time. At any particular instant or particular instant of time. Right? If you want to store multiple values, what you are going to do? In case if you need to store multiple values in a variable, we use the concept of arrays. Concept of array. Correct? Then what is an array? Array is a group of elements. That is the basic thing. Not only it is a group of elements, array elements are of same data type. That means group of integers. Group of integers. Float. Etc. etc. Group of integers. Group of characters. Etc. But not the combination. But not the combination of data types. Everybody knows this. Okay. But in real time, take the data of a student. Take the data of a student. For example, at NIT Nagaland, registration number is integer. I'm talking about NIT Nagaland. Sometimes even you can see, I observed the Swarnandhra College registration number is group of numbers and alphabets. Okay. But I am taking only NIT Nagaland example. We have integers. Name is group of alphabets. Correct or not? Name is group of alphabets. Then imagine CGPA is a floating point number. For example, our registration number will be 2017. I don't remember exactly. Yeah, 105123. This is how we actually give the numbers. For example, Avinash. Some example. Avinash Kumar. Something. Okay. Suppose CGPA is 9.23. Now tell me here the data of the student has many data type values. Many data type values. That means what? One is integer, one is name. So array cannot help us because array takes same data type values only. So this is the reason why we need structures. And everybody understand this structure is not the data structure. Okay. Structure is a concept in C language. It is not the structure in the data structure. Okay. Fine. This is the reason why we need why we need structures in C language. Structures in C language. Let me take the screenshot of this. And now I will explain the board which I used last year for my data structure students. So basically structure is collection of heterogeneous elements, not homogeneous. Homogeneous means same. Heterogeneous means different. Heterogeneous means different. So let me clear the drawings. So from today, I am going to show you the board which I might have used at NIT Nagaland. This is the whiteboard, where I explained the students of NIT Nagaland last year. From making use of this, I will save some time and I will write some other explanation also. Now everybody please concentrate on this part. Why structures are required? Why? I already explained you. Why? Because in real time, you see, registration number is an integer, name is a group of characters, and CGPA is a floating point value. So structure is a group of heterogeneous data type elements. Heterogeneous data type elements. That means, see here, the data of a student. Suppose 101, Abhishek, 9.65. So what you have to do, let me again come back. Why to come back? Here itself I will write. What will happen if we write, something like this? Int registration number in C language. Character name of 20. Then, one second. Character name of 20 and then float CGPA. These three are independent. These three are independent. These three are independent variables which has no relation in the C compiler point of view. For example, if you write individually, what I am actually explaining you, please see here. I am explaining something from here. Everybody, please look here. I have written 3 lines in the program. That's what I mean to say. Now, when you are writing 3 different lines in the program, you know that all 3 belongs to one student, but compiler will not know. What compiler will know? Compiler will think registration number is a variable, separate, name is a character string, basically string, group of characters, and CGPA is a float. All 3 are different. There is no relation. You may understand all are same, but how compiler will know all are same? No. Compiler will not understand all are same. It is something like 3 different pages. You see, one page, another page, and third page. Integer variable, string, and CGPA float. But if you want to bring all together, what you are going to do? You are actually going to bind these 3 and use a stapler and keep a pin. Now what will happen? All are belonging to one particular thing. So how you staple your pages, and also you see any textbook. Textbook is actually individual paper. All the papers are binded together and it is called as a textbook. Are you able to understand what I'm saying? So that binding the variables of different data types into a common platform is called as a structure. Is called as a structure. So how to bring everything together? How to bring everything together? See, as we bind the papers, to make a book, in the same way, binding the multiple data type elements is possible with structures. Is possible with structures. Where it is written, now let me point here. You see this one. Everybody observe. Now I am going to explain this particular part which I highlighted. Okay. So the syntax is you have to write the keyword struct. Struct is a keyword which makes it as a structure. After that, structure name. Some people will say tag name, tag name. Okay, structure name. Then open the curling brace. Inside that, data type 1, member, member 1. Data type 2, member 2. So on. Data type n, member n. Then curling brace close. Then you can give an option as structure variable semicolon. Structure variable semicolon. Now, let me take the screenshot of this and I will explain further by making use of a small program. Till here, any doubts? If you have no doubts, now from the same board, you can't put a function as a members here, I think, Ravi Shankar. I think no, not possible. Now, I am explaining the example now. I hope I have enlarged my class board so that everybody can see clearly. Now you see, I am binding the registration number, name and CGPA into something called as student data. That is the structure name. My structure name is student data. Now inside it, you see there is a curling brace. Now all the three belongs to a single entity. It is like binding. Okay. And these three are members of the structure. MEMBERS, members. And then what is this student here? It is a variable of the structure. Okay, this is the structure variable. But what are these three? They are structure members. This is how you write a structure. Okay. Now, let me clear the drawings and go to the next topic. What is structure member and what is structure variable? Why there are two concepts? Why there are two concepts? Like structure member and structure variable. What is structure member and what is structure variable? Why there are two things? Okay. Why there are two things here? The structure members are placed inside the curly braces. The structure variable can be declared after the closing brace, that is this, or the structure variable can be defined out of the structure definition. What I am actually conveying here, I will write one small example. struct struct, suppose student data, that is the structure, starts, okay, int regno, it is a member of the structure. Then character name of 20, character name of 20. This is also another structure variable. Sorry, structure member. I'm sorry, structure member. And float CGPA. Whatever you are writing inside the structure, they are called as structure members. MEMBERS. And what you are writing outside, for example, yes, here regno, comma name, comma CGPA are the members of the structure, and S is the structure variable. Then what is the significance of structure variable? Why we need a structure variable? Why we need a structure variable? There are two reasons. Two reasons are there. What is the first one? Any structure gets the memory allocation from the structure or from its means its own structure, its structure variable only. That means if you don't give the structure variable, memory will not be allocated at all. Memory will not be allocated at all. I will show you in the program also. And second reason is any member of the structure can be accessed only through the or only through its structure variable only. That means here S is the structure variable. If you don't write yes, you can't simply, for example, registration NO is invalid. It is invalid. Yes dot registration NO is valid. That means structure member can be accessed only through its variable. Only through its variable. Imagine in a class before the before the corona, some students are sitting in a class. Somebody came and locked the door and locked it, and he kept the key and went out. Now just imagine, inside people are the members of the class, and the guy who has the key, he is the variable, structure variable. Only if we open, there is no breaking the door concept. Okay, sir, I will break the door like a hero and come out. No, not like that. Only when the key is open, then only I can access the members. In the same way here, the variable is the key for the structure members. Okay, let me take the screenshot of this, and now I will show you the class drawing, class board. Now you see, accessing structure members, there are two operators. There are two operators. One is dot. One is dot. What is dot? Where I am explaining here. I am explaining here. There are two symbols which are used for accessing the structure. One is full stop, that is dot. Another one is arrow. In our keyboard, there is no arrow. So minus and greater than symbol together is called as an arrow. Okay. So when we have to use arrow, when we will use arrow and when we will use dot. One second. My mouse is not listening to me. Yeah. Now come here. If the variable is a normal variable, if the structure variable is a normal variable, that means, see here, if the structure variable is a normal variable, then structure variable dot member. If the structure variable is a pointer, then structure variable arrow member. Arrow member. For example, let me show you in the class board itself. See here. Let me tell a program. Why? Because so much of theory also is very boring. I myself got bored. Right? NPP structures.c. Now, to understand the concept of structures and why we are actually studying structures, because in real time your data is of multiple data type elements always. Your data type is always having your data has multiple data types. So it is always good to use structures. And by making use of the concept of structures, I will implement linked lists, trees, and graphs also. Right? Now, hash include stdio.h void main, and then, for example, struct. See, it is not directly int. Struct, suppose student data. It is a structure. It is a structure. Now, struct student data and then int registration number, character, name of suppose 20 characters, then float CGPA. Now I will put semicolon. See, I have not given any structure variable. I have not given any structure variable. Then integer take 4 bytes. Correct? Integer take 4 bytes. Ideally, character means 1 byte, 20 means 20 bytes. Then floating point also 4 bytes. Ideally, it needs 28 bytes. Total 28 bytes required. But as long as or if no structure variable is given, at this point, no memory is allocated. That's it, very simple. Then when it will be allocated? Only when you give the structure variable. Structure variable can be given in two places. Structure variable can be given in two places. One is before the semicolon, or you can also give separately struct student data, that is the struct. Yes. Now this is one way. Here 28 bytes are allocated. Sir, how I know, sir, 28 bytes are allocated? Very simple. See here, printf %d, comma, sizd, size of. There is a function by default, size of. Yes. I gave size of yes. Now you can see definitely 28 bytes should come. Because I gave yes. After that, I will remove the yes and I will show you what will be the size. Let me simply execute first. Structures, right? Yeah. Oh, I have given wrong command, -o. Oh, so many errors are there. What are the errors? Correct only, right? struct, size of yes. Oh, size of struct. It's correct only, right? Is it given like this? No, I think. I have done a small mistake, I think. Okay. Yeah. Hyphen is not allowed. Sorry. Hyphen is not allowed. I have done a small mistake. Only underscore is allowed. Sorry. Student underscore data. Hyphen is not allowed in giving the variable names. Okay. Now let me recompile the program. Let me recompile. Yeah, it has successfully completed. Everybody understood? The size of the structure is 28. Size of the structure is 28. When? Only when you use the structure variable, only when you define the structure variable, from here only you are going to get the size. Okay, let me take the screenshot so that I can share. Now, let us change the program. I don't want to, I will just do one thing. I will make it into a comment. Which line? This particular line. And for that point, let me just do one thing. If I put so many comments, it will be very confusing. So let me remove it and printf %d size of struct student underscore data. Means I am directly asking what is the size of the structure student underscore data by calling the function size of. Okay, I save the program and please observe here, I am not giving any structure variable, but structure is declared. Structure is declared, but there is no structure variable. That means let me execute and see if there is any. I am recompiling. GCC -o recompilation. Now compilation is successful. I am fingers crossed. Oh, because I used size of struct student in this particular function. Please observe, in this particular function, I am passing the structure student data. That's why forcibly it is showing 28 bytes. But ideally, only when the structure variable is given, then only in the memory something will be created. For example, I will tell you, if memory is created, in this print statement, don't get confused why 28 is coming. Directly I will say registration number is equal to 101. If struct student data has some memory, then what should happen? This should work. Name is equal to Raju and CGPA equal to 9.23. CGPA equal to 9.23. So I will print %d registration number. After that, print. Okay, I can say PUTS, put the string, or I can say printf %yes name, and then printf %f CGPA, %f CGPA. So let me keep the new line. Let me keep the new line. Save the program. Now recompile it. Now you see it says, I don't know REGNO. It is undeclared, it says. Okay. Even it says, I don't know what is name. I don't know what is CGPA, because they are not having any memory location at all. Why? Because only, but in the size of, because I explicitly called the size of function, it forcibly showed me 28, but ideally it is not having any location. That's why it does not know what is REGNO. Then what to do? You put yes here. Either you put yes directly in the definition of the structure, or after that you can write struct to student data yes. Now yes dot registration number, yes dot name, yes dot CGPA. Similarly in the output also yes dot and yes dot. Okay. Now let me compile the program. Let me compile the program side by side. Clear the screen, recompile it. S dot name equal to Raju. Okay. So why s dot name equal to Raju should come. Okay, because it is a character, maybe it is not taking or what. I think I should do a string copy or what. So let me try in another way. Hash include string dot h, and then I can say strcpy, copy the string s dot name from Raju. I don't know whether it will work or not. Let me check. Yes, it has not directly taking the group of characters. So what I have done, I have used a string copy function and copied the string Raju into s dot name. Now you can see through the structure variable only, through the structure variable only, through THROUGS, through the structure variable only, the members of the structures can be accessed. Directly, if you say, it will not come. Through the members of the structure only, we can access the structure. Okay. From here to here. Let me take the screenshot of this. Now, this is one way of accessing the structures. The second way is by making use of a pointer variable. Second way is by making use of a pointer variable. Okay. Let me close the program and create one more program. From the same, copy structure.c as structures1.c or with pointer variable, with pointer variable.c. Structures with pointer variable. So I just copied the program. Let me open it and change it. Because to save some time, with a pointer as structure variable. I just want to save some time, so I copied the program into another file. Now, instead of yes, I will give star s. I'll give star s. So here, s is a pointer structure variable. Star s basically. Normal s is a normal structure variable, but here it is a structure variable, but it is a pointer. In this case, you need to keep minus and greater than. Always you have to put to differentiate again the access of normal variable and pointer structure variable. We have to use arrow. Arrow means minus and greater than. You can use anything, but from linked list onwards, I will tell you when there is a normal variable, yes, what is the meaning and what is the application of star s having a pointer structure variable. I will explain from the data structures topic of linked list onwards. As of now, try to understand normal variable dot, pointer variable arrow. Let me again GCC minus O Now let us execute. You will get the same output. Why? I don't know why it has not come. Okay. Banu Farindra is asking a doubt. How you know it is 28 bytes? It is very simple. Integer is 4 bytes. Character is 1 byte. 20 are there, so 20. Floating point is 4. Altogether 28. That's all. Altogether 28. Why this is not coming? Just now I told Swami, please wait till the linked list. I will tell you when there is a normal variable yes, why we are using the pointer variable. I will tell you. Okay. So as of now, I will just check this, why it is not coming. But let us just continue. Let us continue our topic. So I already gave a big explanation here, which I am going to share with you. You people can read, you will also understand. Case 1, 26 byte. What is case 1? I have given two structure variables here. Then 26 bytes and 26 bytes total 52 bytes. For example, please see here. I will try to highlight and show you. What is case 1? Case 1 is here. I have one normal variable and one pointer variable. So for student also 26 bytes. See, I am writing 26 because in Windows operating system, some compilers takes integer only 2 bytes. In that case it is, but in this GCC my system, it is taking 4 bytes. So don't get confused with integer with 2 bytes and integer with 4 bytes. Okay. So if you take a normal Windows operating system, 2 bytes are there. So, but in our case, for example, let me just come here, clear the drawings and open the program npp structures.c. For example, here you will put star p. Then what will happen? For S, 28 bytes. For P, 28 bytes. Total 56 bytes. You write one more, you will get one more 28 bytes. For each and individual structure variable, you will get the size. But if you don't write anything, no bytes. If you don't write anything, no bytes. That is what was explained here. So after that, now you see array of structures. Array of structures. What is array of structure? For example, let me write array of structures. Array of structures. Array of structures dot C. And let me copy this particular program and paste it here to understand the concept of array of structures. Only two concepts are left out. I am going to take, I started at 5:10, so I will take till 7:10. If anybody has issues, you can log out and you can watch the YouTube session. If anybody has any timeout problems, don't stop my class till 5:10 because you came 10 minutes late. So I am going to take additional 10 minutes. Fine. Now, what is array of structures? Very simple. I will give like this, or I will let me give only 3. A structure variable, a structure variable which is an array is called as array of structures. Then why it is required? When normal S is there, why I have to write S of 3? Right? Let me tell you why I have to write. For example, you put like this, only S. But I want 3 student names, 3 student data. What I will do? Again, if I give REG and O, what will happen? The old one will go. What I have to do then? If I have 3 students, so I will say student 1, comma, student 2, comma, student 3. Then what will happen? Student 1 dot registration number. See here. Everybody please observe what I am doing. If I want 3 students, then what I have to do? Simply let me take S1 so that it is easy for me to change the program. S1, S2, S3. So this is S1, 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 1 and 1. Now S2, student 2, suppose 102. Okay. Then here are everywhere student 2 in the second record. I can say Ramu. Then 7.23 or 7.35 or 67 something. S2. Here also S2, S2, S2. Now 103. S3, S3, S3. Imagine it is 8.00. Then everywhere I can give. So if I need 3 students, if I need 3 students, I have to give 3 times. And just imagine how many times I have given the common thing. If I have 100 students, will you give S1, S2, S3, S4, S5 like that S100? It is not proper, but this is one way. If you have, so let me just copy. There is no array of structure here. I am just explaining why we need array of structure. Why we need array of structures. In case if you have multiple, oh, what is that? Array of structures.exe. Yeah. Now you see all the 3 will come. Only 2 came. Yeah, all the 3 came. You see, first student, second student. Oh, where is the number of the guy? It is missing. Let me open the program. Oh, it might have come in the side actually, because backslash n is missing. Don't worry, there is no problem in the program. I'm going to take another 8 minutes. It's getting compiled. You always remember, some machines will take integer 2 bytes. Some machine will take integer 4 bytes. So when I'm writing on the board, I might have written 2 bytes. So don't get confused when I'm sharing the notes. Now you see, first number, second number, and third student data, which looks very awkward, right? Why it is awkward? Why? Because the length of the program is big. The length of the program. So using several structure variables makes the length of the program proportionate sometimes I will forget my proportionate to the, or you can say, see, in a simple terminology, the number of variables, structure variables, number of structure variables are directly proportional to the number of lines in the program. Program will become lengthy, which is not good. Program becomes lengthy. So what we need, so we can use the array of structures. We can use array of structures. So let me take the screenshot, clear the annotations, and then change the program. Change the program to something like this. S of 3. S of 3. Okay. Then to see printf enter registration number, name, comma, CGPA of 3 students. One simple message I have displayed. After that, I will take one int I, one control variable. Okay. Then for I equal to 1, I less than or equal to 3. Oh, because the index always starts with 0, I can say I less than 3, I plus plus. I hope everybody knows the index of array concept. So here, what I will do is scanf, okay, percentage %d or, yeah, scanf percentage %d, comma, S of I means S of 0 dot registration number. It will go there. Ampersand S of I dot registration number. Similarly, for reading the name, because directly it is not taking. So what I have to do is I can first directly take the name. Okay. Let us not take the, oh, if I am taking the name, always the same name will come. So what logic we will write? Okay. I can say printf enter the registration number, then scanf, that one. Now printf enter the name. Here what I will do is I will define one character temp as 20. Okay. I will read like PGETS inside the temp. Temp is the string. After that, what I will do is string copy S of I dot name, comma, temp. Whatever you are reading in the temp, it will be copied. After that, printf enter the CGPA. Then scanf percentage %f S of I dot CGPA. So in a single loop, I could do, instead of 9 lines, 3 times registration number, 3 times name, 3 times CGPA, I could use only, don't see the printf statements and count the number of lines here. Okay, only scanf and this string copy and again scanf. Only 3 lines are written. So after that, if you want to print, what you will do? You can simply take the same thing in a loop. Okay, and then printf \n %d s of I dot registration number. After that, printf \n %s of I dot name, and then printf. This is the last concept. Okay, tomorrow we will see one more concept in structures, that is self-referential structure and then dynamic memory allocation. This is the last concept of the day, CGPA. And now let me try to execute, because after so long time I'm actually writing a program. Because it is a online, I have a chance to write the program and execute in front of you. Sometimes I may do a mistake. Ambedkar sir, you are saying please change the structure variable as S of I. And another person, Ajay Venkat, see there are many ways to give. I can use a pointer variable also. But first let me explain the simple thing. And somewhere did I do a mistake? Ambedkar sir, where I did a mistake? You are saying please change structure variable as S of I. Where sir? In which line sir you are asking? Ambedkar sir. In which line I have to put S of I? Everywhere I put S of I only, right? S plus I, in 23rd line I missed. In line number 23, it's there, right? S of I. Line 13. No. Line 13, no. Line 13 is correct. You can't say here S of I. Ambedkar sir. Line 13 is an array. Array, can you declare something like this? Int A of I. Can you declare like this? No. You have to give the size. Okay. And some more people are asking me, put S plus I. Let me please execute. S of, sir, instead of string copy, you can use get S of I dot name. Okay. Karthik sir, I can understand. Earlier, I was not getting the directly S dot I in the thing. That's why I just copied extra. So let me first execute. See, there are many ways to write a program. I am always writing a more simplest way so that everybody will understand. I am not telling whatever I am writing is the efficient program. No. Let me first execute the purpose of array of structures. Slowly we will change. Now we will see, yes, enter the registration of the, enter the registration number 101. Oh, here the name is coming out because of the problem. One problem is there here. The problem here is, after reading the integer, when you are reading the string, it needs flushing the memory. It needs flushing the memory. So F flush stdin. F flush. If you have any doubt, you please go through my recorded videos. of the strings concept, stdin. That's the problem, I think. When some compilers does not take integers and strings together, oh, semicolon is missing. So let me execute. And enter 3 student, registration number 101, name Raju, then CGPA 5.67. What happened here? In between the automatically it stops. I don't know. I don't know why execution problems are coming. So let me anyways check in the background. But that is the concept. Okay. Let us revisit the same concept tomorrow. And then I will explain one more concept, which is self-referential structures. Self-referential structures. That concept and the execution we will see tomorrow. Some problems are coming right now. The time is 7:15. Oh, line 23 add ampersand in line 23. Okay. Yes. Correct. I missed ampersand in the CGPA. Thank you for correcting me. Thank you. In a hurry manner, I forgot the basic. That's correct. Thank you. GCC. What happened here? Can't open output file. Permission denied. Okay. So I will. Access is denied. Why? Oh, it is still running in the background. That's why. Oh, sorry. Yeah. Let me recompile. And then execute. 101. If I do, I will not give my name because some errors are coming. 9.99. Sachin Tendulkar name I will give. Then 102. Dravid. Okay. Let me give 9.89. Then I will give 103. Ganguly. Okay. I will give 9.78. Now you can see the values are coming by making use of array of structures. By making use of array of structures. So let me take the screen. So today one topic is left out, that is self-referential structures. Tomorrow I will explain self-referential structure and start with dynamic memory allocations. Now tell me if you have any doubt, please ask me. Over to the host institute. Thank you all the participants for your valuable time given to us. And I thank the Swarnandra College management and all the organizers who never stops me when I am extending the session. Anyways, I took only 7 minutes extra. I started 10 minutes late. Thank you guys. Over to the host institute now. Sir, you can unmute, sir. If any doubts are there, please ask me. Srinivas sir, you are still in mute mode only, sir. You are not able to unmute or what? Let me see. Okay. I understand. I asked you to unmute, sir.
Thank you, sir. Thank you. Such a great, wonderful session, today's session. Thank you, sir. Any feedback from students' point of view?
How to make you as, who is the host, sir, right now?
I think Ramakrishna, sir.
Oh,
Sir,
I am
sir.
already, yeah.
Sir. Good evening, sir. Nagaraj, sir.
Good evening, sir.
Sir, website is working, sir. 16 days website,
Okay.
sir.
Yeah.
Okay.
One of the student is asking, what
Yes,
is F-flush? Botsa Harini. See, some compilers, when you are reading the values from the keyboard, like mixture of integer, strings and floating point, especially before the string, If you are using any other data type, the buffer should be cleared. Buffer should be cleared. That's why plus the buffer standard input, STDIN means standard input, plus means clear the buffer. Another person, Hari, is asking about what is the difference between structure variable and pointer structure variable. As I already told you, if it is a normal variable, you can do only reading the values and taking the values. But if it is a pointer variable, you can actually play with the addresses. Tomorrow, I am going to explain self-referential structure. Then you will understand the real beauty of using a pointer structure variable. Just wait till tomorrow. Yes, if somebody wants to give a feedback, I think electronically you can raise your hand. Any more
Sir.
doubts?
Yes, feedback, sir. Feedback, sir. Madam, giving feedback, sir.
Yes, no problem. Yeah.
Anjali, welcome to Anjali, giving your valuable feedback to this session. I will call Vandana also. Soumya Sri. Soumya Sri. Good evening, madam. Soumya Sri Garu. Please give your valuable feedback on this session. Soumya Sri. Unmute yourself. Soumya Sri. Sir,
Yeah,
host Dilip sir. Sir, you can unmute. You can unmute Soumya Sri student for giving feedback, sir.
And Bhaskar Teja, you are right only. In self-referential structure, not only double linked list. Any linked list we have to use, not only double linked list.
Dilip sir. Sir, please unmute the Soumya Sri, sir.
Soumya Sri unmute. There are two Soumya. Roll number 478, roll number 539. Which Soumya, sir?
18, sir. Starting 18.
Both are 18 only, sir. I asked both to unmute now. Yeah. Yes, sir. I think better we will quickly do it, sir. If somebody wants to give feedback, quickly unmute yourself or you unmute everybody, sir, so that anybody can speak.
Soumya Sri giving feedback on this session.
I hope you people are able to understand the in-depth concepts of the memory locations and the concepts of foundations of the data structures. I'm just waiting for the feedback. If there is no feedback, then I can leave the session.
Okay, sir. Nagaraj, sir.
Yeah.
Close this.
I can-
Okay, sir.
Okay. Okay, sir. See you guys tomorrow. Thank you.